was really interesting to zoom into just a particular materiality and to just really focus on a material for a whole semester, and specifically wood is a very interesting one.
The name of the studio is Wood Proto-Architecture. I think one of the most interesting parts was thinking about material intelligence, not just about structural properties or aesthetic properties of the material, but how we could really start looking at the material's intrinsic properties when we start designing things. We made a series of models investigating the behavior of wood.
I think to program a natural material is very interesting. We kind of control everything to let this piece bend the beautiful shape for this. So we can, I feel like to control this natural element and program them is very cool.
Essentially, this is a natural phenomena that happens all the time, and I think like traditionally with a lot of wooden construction, the point of it is to keep it stable and it's to make sure that it's not bending. But wood wants to do that, and that is something we were trying to leverage at different points in different places in our final model, and to sort of create this more this like larger composition which had multiple bending curvatures. When we first put this in the exhibition, it was flat. Now we're just removing the training wheels because there's no longer a need, because it's standing on its own.
As you look through the work of the studio, you can see how sort of the rigor of research is very well complemented with a fantastic inquisitiveness and imagination. I thought the wood prototyping studio was a fantastic experiment, not only in terms of material properties, but also in models of collaboration.
And we started with this original opaque piece of wood, and we created a translucent biocomposite with epoxy resin through the chemistry department.
The way it all began was I emailed someone in the chemistry department, so it was quite a happy coincidence that we were able to collaborate.
What really piqued our interest about this research was the potential for it to be kind of a new material, and that it was going to be stronger than wood, a better insulator than glass or wood, and as well as having the optical translucency and even transparency with some of the preceding research. Kind of just gave us the idea that it'd be really exciting to play with this more and kind of to see what it meant as an architectural project, not just a chemistry project.
What can this type of material do for the architecture field? Whether it's window panes in a skylight or actual structural wood beams, what is the kind of potential that this translucent material can have?
This is our final installation, kind of everything that we've learned culminated into this final project. So this one actually has 2 different thicknesses of wood in it to kind of create that range of transparencies.
For me, looking at a material closely, looking at wood as a biocomposite, and especially with the demands of the building industry, we're coming to an age where that really does have an effect on our environment. So the more sustainable approach of, okay, let's look at wood in a different lens. Let's try and see it as a different material to then blend kind of the sustainable aspect into architecture.